Hey everyone! Today we're diving into one of the most fascinating topics in science, the periodic table and whether it has a limit. You know that colorful chart you see in your chemistry classroom? The one with all the boxes labeled with symbols like H for hydrogen and O for oxygen? That's the periodic table, and right now it has 118 known elements. But here's a fun question. Is that really all there is? What if we could discover more? What if just maybe there's no end at all? Imagine if scientists one day stumbled upon some crazy new element with wild properties, something straight out of a sci-fi movie. There's even a fictional one called Unobtainium that shows up in movies. The name says it all. It's supposed to be so rare and powerful that it's basically impossible to get. But let's set that aside for a moment and focus on something a little more familiar. Good old carbon. So, what makes carbon carbon? The key is in the number of protons. Every element is defined by how many protons it has in its nucleus. Carbon has exactly 6 protons. That's what gives it its identity. You can't just add or remove a proton and expect it to stay the same. Change the number of protons and you get a completely different element. But carbon isn't always exactly the same. It has different versions called isotopes. These isotopes all have 6 protons, but they differ in the number of neutrons. For example, carbon-12 and carbon-13 are stable, meaning they don't fall apart over time. Carbon-14, though, is a little different. It's radioactive, meaning it slowly decays into something else. The cool part? This decay happens so slowly that it takes about 5,730 years for half of it to disappear. That's called a half-life, and it's how scientists date ancient fossils and artifacts. So next time you hear about something being carbon dated, you'll know it's all thanks to this weird little radioactive cousin of regular carbon. But not all elements are so chill. As you move higher and higher up the periodic table, adding more and more protons, things start to get a little unstable. Why? Well, inside the nucleus, you've got all these positively charged protons packed tightly together. And as you probably know, like charges repel each other. So what's keeping them from flying apart? That's where the strong nuclear force comes in. It's one of the fundamental forces of nature, and it's what holds the nucleus together. But here's the catch. This force only works over very short distances. So as atoms get bigger and the number of protons increases, the repulsion between them also increases. At some point, that repulsion becomes stronger than the strong force holding everything together. That's when the nucleus becomes unstable and starts to fall apart. That's why elements heavier than lead, element number 82, don't have any stable isotopes. They all decay sooner or later. Scientists have actually mapped out every isotope we've ever discovered, and they noticed something interesting. If you plot them all on a graph, the stable ones fall along a kind of curve known as the valley of stability. Everything outside that valley is radioactive to some degree. The farther away you go from the valley, the more unstable the isotope becomes. But here's where things get really interesting. If you extend that curve further, you reach a region called the island of stability. This island is just a theory right now, but scientists believe there could be some super heavy elements out there that are unusually stable, at least more stable than expected. Maybe they'd last long enough for us to actually study them. A few atoms of these kinds of elements have already been created in labs, and while they didn't last long, they hint that the island might be real. So how far can we push the periodic table? That's still a big question. There's a famous, maybe even a bit mythical story about Richard Feynman, a legendary physicist, doing a quick calculation on the back of an envelope. He figured that once you hit atomic number 137, things get weird. The electrons around the nucleus would have to move faster than the speed of light to stay in orbit. But that's not possible. Einstein already told us that nothing can go faster than light. More accurate calculations today suggest that the limit might not be exactly 137, but closer to 172. That means we might still have room for more elements to be discovered or created in labs. After that, though, our current theories start to break down. But wait, there's more. Some scientists believe that if you keep increasing the mass of a nucleus, you eventually reach a point where protons and neutrons can't stay as they are. Instead, they might break down into their smallest parts, called quarks. You've probably heard of up quarks and down quarks in physics class. When you cram enough matter together, like in a supernova or a neutron star, you get what's called quark matter, a dense, super strange soup of particles. These aren't really atoms anymore, and they definitely wouldn't fit on the periodic table. But here's the wild part. They might actually be stable under those extreme conditions. So in the end, we're not exactly sure how far the periodic table can go. Maybe it ends somewhere around 172. Maybe it goes further. Or maybe we stop thinking in terms of elements entirely and start exploring completely new forms of matter. What we do know is that the universe still has plenty of mysteries left, and the periodic table might just be one piece of a much bigger puzzle. Who knows? Maybe one of you will be the scientist who discovers the next element, or even something totally unexpected. The future of science is wide open,